All right, you guys, sorry about that. This is lesson 4.3, part 2 for geometry, because I had a little problem. But anyhow, we are in the middle of, or I guess, the bottom part of page 4 in the notes. We're looking at vertical angles, so we're right here. Don't forget that vertical angles are congruent. We were talking about this problem right here. And we had established that the left little triangle here was side, angle, side. The right triangle was angle, side, side. And since those aren't the same, you can't use them. If we bring in vertical angles here, so a vertical angle here, this angle is equal to that angle by vertical angles theorem. Remember, vertical angles are two angles made by the same segments. And so I know then that this angle right here is congruent to this angle right there by the vertical angles theorem. So then I check, and let me switch colors again here. And when I check now, I have side, angle, side, but yet over here I still do not have side, angle, side. Looking again though, I could also say I have side, side, angle. Side, side, oops, angle. And over here, I would have that as well, side, side, angle. But there's a problem there. Hopefully that set an alarm off in your head, because side, side, angle is the same as angle, side, side. And remember our rule, we don't swear in math, nor does side, side, angle, or angle, side, side work. So we cannot use that either. So we're looking for what else could we use here. And another way to look at this then is, let's say I forget about this, all right? Forget about that segment. And so I'm going to use this angle, and this side. And I have angle, angle, side. Now that works, angle, angle, side. And will it be the same over here? So I have this angle, and this side. And so yes, I have angle, angle, side here as well. So therefore these two triangles are congruent by angle, angle, side. This would be an honors level problem for you to look at this picture with this information and figure that out. But regular geometry, you should know and be able to recognize the old vertical angle thing. You should know that side, side angled is not a viable option, nor is angle, side, side. We can never use those. And then you should be able to understand that if you go angle, angle, side, angle, angle, side, you can prove that those triangles are congruent. All right, and we also don't want to forget about looking for parallel lines and alternate interior angles. So remember, when you have parallel lines, and that's what these arrows mean, these lines are parallel. And remember, if you have two parallel lines and a transversal, alternate interior angles would be this angle is equal to this angle. These are my parallel lines. Or this one is equal to that one, alternate interior. So in this picture here, since I have parallel lines, this would be my transversal here. This angle right here is equal to this angle right here. So how can I prove these two triangles are congruent? I have this side is equal to that side. They're marked. I have these two angles because of alternate interior angles. And then finally, I have this side is part of both triangles. It is congruent to itself. So therefore, I have side, angle, side. Or here in this case, side, angle, side. So by side, angle, side, congruence postulate, I can say these two triangles are congruent. So I would say ADB is congruent to A goes with C, D goes with B, and B goes with D. And I could say those two triangles are congruent. Okay, so what we're going to do now is just some really quick problems here to say, are these two triangles congruent? If so, list the postulate or theorem, which means the shortcut that proves them congruent. So here we go. First one. I have this side equal to that side. I have a 90-degree angle, so I have that angle equal to that angle, and then I have vertical angles. Those are equal. So therefore, I have angle, side, angle. Angle, side, angle. So I would say, yes, they're congruent by angle, side, angle, congruence postulate. Next one. I have this side equal to itself by the reflexive property. I have this side equal to that side, this angle equal to that angle, and I have ASS, which I can't have. And this one would also be ASS, which I can't have. Therefore, these are not congruent. If you cannot come up with one that works, it's not congruent. You may not use ASS. All right, next one. I have a 90-degree angle on both. I have a 3 and a 4. So therefore, I have side, angle, side. Side, angle, side. Side, angle, side, congruence postulate. Next one. I have a 90-degree angle. I have a side, and I have this middle one, which is the hypotenuse. Now, if I just look at it like normal, I would have angle, side, side. Angle, side, side. You can't swear, that doesn't work. But because I have right triangles, I can use the HL postulate. The hypotenuse is the same for both. So by reflexive property, those are equal, and the two legs are equal, and I have right angles. So that's the HL postulate. Next. H equals F. Those angles are equal. This side equals that side. And then this is equal to itself by the reflexive property. And if I just go on that information, I have angle, side, side, which again is ASS. We can't use it, so we toss that out. But we're not done. We want to keep looking. Now, the next thing, if you remember this big triangle has these two angles congruent. And those are the base angles. And if those base angles are congruent, then these two sides are congruent. That is called the converse base angles theorem. And now, if I use these two sides, I have side, angle, side. Side, angle, side. So those are congruent. Next one. 4, 6, 7, 4, 6, 7. All my sides are equal. I know nothing about my angles. That would be side, side, side. Next one. If this is a 90, then this is a 90. This, oh, sorry about that. This, of course, is congruent to itself. So I have angle, side, angle. Angle, side, angle. Angle, side, angle. Next. This is congruent to itself. It's reflexive. So I have angle, side, side. Angle, side, side. But angle, side, side does not work. So the answer is no, not congruent. Next, we have this side equal to itself. We have parallel lines, which means this angle is alternate interior with this angle. But we don't have anything else. All I have is an angle side. Not enough information, so no, not congruent. Next one. This angle I know equals itself, vertical. So I have side, angle, angle, side, angle, angle, side, angle, angle is the same as angle, angle, side. And so yes, but write it this way, angle, angle, side. Last one. Look at that. I have side, angle, side. Side, angle, side. Another way to look at that is I also have parallel lines here, right? So therefore, this angle equals this angle, alternate interior angles. in which case I would have angle, side, angle, angle, side, angle. I also know that this angle equals this angle, also alternate interior angles. So there's a whole bunch of reasons. You can also get angle, angle, side out of that. So lots of reasons. Any of them would work as long as they're legit. Not the last problem, but another problem. Find the value of x so that the triangles are congruent. Then list the postulate or theorem that proves them congruent. Okay, so I want these two triangles to be congruent. I already know this side equals this side. I need to get this side equal to that side, right? So that means I can set up an equation. 20x equals 22x minus 3.6. And then this side, of course, is equal to itself. So I'm going to use the side, but first I have to find out what is x going to be. So I need to solve that equation. So I'm going to subtract my 20, and I'm going to add my 3.6. So I have 3.6 equals 2x. Therefore, x has to be 1.8. So if x equals 1.8 units, then side, side, side works. Next one. So here I have this side equals this side equals that side. And so it looks a lot like, and then I have this one going with that one, right? That would be the side angle side, correct? But in order to do side angle side, these two angles have to be equal. So I'll say 4x plus 7 has to equal 6x minus 27. Solving that, I get 2x, I subtracted the 4x, add the 27, and I have 34, so x has to be 17. So I could say, if x equals 17, then side, angle, side works. Next one, show that angle or triangle ADB is congruent to CDB when t equals 4. So what you're going to do here is you're going to put 4 in for t and see what happens. So here's a t, here's a t, and here's a t. Now notice that this and this, those are side lengths. So I need to prove these triangles are congruent when t is 4. So if these triangles are congruent, then 3t plus 1 has to equal 4t minus 3 when t equals 4. So let's put that 4 in there. 3 times 4 plus 1, does that equal 4 times 4 minus 3? Well, 3 times 4 is 12 plus 1 is 13. 4 times 4 is 16 minus 3 is 13. So yes, it works for the sides. But now I need to do it for my angles. So 32 degrees has to equal 2t squared when t is 4. So I'm going to put 4 in there. So that means 32 has to equal 2 times 4 squared. 32 has to equal 4 squared is 16 times 2 is 32. Yes. And so that would be the type of thing you need to do here. You have to say, okay, well, if these triangles are congruent, then I'm going to write my equations like we did here and plug in the 4 and prove that they are congruent. Last problem. Show that triangle ABC is congruent to DBC when x is 6. So same type of problem. This is an angle. I look for those little degree signs. So this angle has to equal that. So x plus 20 has to equal 26. Put x equals 6 in, so 6 plus 20 equals 26. Yes, it works there. Then this side has to equal that side. So 3x plus 10 has to equal 4x plus 4. Put our 6 in. So 3 times 6 plus 10 has to equal 4 times 6 plus 4. 18 plus 10 is 28. 24 plus 4 is 28. Yes. And so there you go. We did it. And that is the end of lesson 4.